Out of arrays and talk about classes. We've already talked about structures. A class is just a structure with functions attached to it. I believe we're in, I don't know why I defaulted back to going to repos. Please go to where I want you to go. All right. So many environments will populate your .c file with enough to get going without having to go grab the boilerplate. But Visual Studio, as awesome it is, and it's just about the most powerful C++ development environment that I'm aware of or have used, doesn't.
We're using the boilerplate with the upstream in it?
Yeah. Well, I'm not sure we'll write to a file, but why not? Nothing wrong with bringing in too many things. Doesn't slow it down. Because once it's done compiling, all of this stuff is gone, and it runs just as well as if it hadn't been there to begin with. All right. So we've been learning about arrays. If you need to copy from one array into another one for whatever purposes, you do it with a loop. There's probably a function for doing that as well. Let's yeah, here we go. So if you're going to copy one array into another, this is absolutely not how you do it. And this is true of Python, it's true of Java. All this does is take the memory address that this array is stored in and copy it into this variable. So now you have two pointers to the same array, to the same data, to the same memory address. It's like having two street signs for the same street. You go and you burn down all the houses on that street. You've got two street signs now pointing down to burn down houses. It didn't make a copy of the street just because you put a new sign up. So instead, you copy the element, the stuff's element by element with a for loop. For loop's the simplest way. For loops are usually the simplest, loops of all. So what if we make a data array, int data, and I don't know how long it's going to be, so I'm just going to put, square brackets there, and I'm going to put some data in it. I don't care how many. Now I want to create a new array that is a copy of the data array so that I can change the values in it while preserving data. Like what if I wanted a new array and every value in it was going to be, a percentage instead, right? Or something like that. So I'm going to be modifying the new array. I don't want to touch the original one. So in data 2, but we do need a size. We don't have a size here. So const int data underscore size or array size equals, and how do we get the size of an array? Size of the array in parentheses divided by the size of one of the elements. They're all ints. Now some people will do this. I'm going to type it and then I'm going to undo it. This is not a bad idea, but there can be times when it would crash. You could say, I want the size of the first element in the array, rather than hardcode int. Why would you do that? Because what if you came back and you changed that to long? If you had int here, size of int, it's no longer correct, right? Because you declared it as being longs. So this is a great idea. The only problem is if this array is of length 0, which is perfectly valid. You can create an array for whatever purposes of length 0. Then when you try to access element 0 to get its size out, it's going to crash. So there's an advantage to doing it like this, But the drawback is if you suspect for any reason that the length of the array, the size of the array might be 0, you don't want to do it that way. One example of when an array might come in with a length of 0 is if there are no command line parameters and you're checking for command line parameters, right? Like the dir command. You can type dir and it'll give you a list of all the, the files in that directory, but if you type dir space /od, that means order by date, well, that's a command line parameter, and that gets passed into this program as an array. Each command line parameter is a new element of the array, but if there aren't any, I think I'm making a slight mistake in that example there. But anyways, you can make an array that has a length of 0. That would cause this to fail at runtime. I'm going to go back to just using the data type and being careful about it. Right there. So I need to make a new array of the same length because it's supposed to be a copy of it. I could initialize it to 0, but there's no reason to. Excuse me, that's Python. There's no real reason to initialize it to 0 because I'm just going to copy the contents of the first array into it. But there's no harm in it, except to initialize it does take a small amount of time. But I feel safer when I initialize something to 0, so I'm going to leave that there. And now I'm going to write a for loop that copies all the elements from data into data 2. So I just need I, right? An index counter. For parentheses int I is equal to 0, semicolon. I is less than, I could do it like this, data underscore size. Why not? Because I already have that variable just sitting there right in front of me. Semicolon, I plus plus. And then data 2 subscript I is equal to data subscript I. Right? Go through item by item. Traverse your data array, copying it into the new array. That's how you make a copy of an array. I am reasonably sure there are functions built into the language to do things like that for you. Like array function C++ copy. See, let's see if there's a function to copy an array. Okay, there's mem copy, which copies it byte by byte. And you can use std : array to do it. And I'm not going to do that. That's pretty variant from classic C language. It's using features that were added in 1911, but we're going to leave it alone. This is interesting to look at, though. Seems to be showing that you could create a new array that is the same as the first array by doing that. This seems to be a new beast, standard array. So it's not an array in and of itself. It's an object that contains an array and another piece of data that contains a size. Well, lo and behold, we're going to be talking about classes, and so we could come up with something similar ourselves. And it's nice that they finally got around to adding this to C++ because Java has had this idea since the early 90s of tracking with the array how many elements are in it, right? So that we don't have to do this size up business to count how many elements are in it. All right, so if you came in late, you don't have to do this part because we're going to move on. Printing the contents of an array. Just use a for loop. Like this. Same business here, right? We happen to know the size of the array, but let's make a new one. Double space DA for double array is equal to, and we can put some numbers in it. Whatever, just throwing periods and commas with reckless abandon. Right. We're going to write some code that will copy through that. Again, we're going to need to know the size. So again, we're going to calculate the size on the fly. However, we could just do it right in the for loop rather than do it in the variable, but I'll explain why I would prefer not to do it after we code it this way. First time I code, it's going to be like the shortest number of lines to do it. For parentheses, int I, it's an index-based loop, equals 0, semicolon. I is less than what? Well, we know how to get the size of an array now. We've done it a couple times. Size of parentheses, dA, in parentheses, divided by what? Size of parentheses what?
Double.
Yep, double. Semicolon, I plus plus. All right, now, this works beautifully. It works perfectly. The only problem is it gets reevaluated every single time. Right? It's a little bit of math. Just slows it down just a hair. If you cared, you would store that result in a variable beforehand, right? dA underscore size equals, and then you could cut all that, and you could paste it there, end it in a semicolon, and then you could go while dA's, while I is less than dA size. That's preferred. Why am I getting an underline there? Let me save it and see if it goes away. It did. All right. And then I could print out the element. Right? Cout less than. What's the name of the array? dA. What's our index? I. So dA subscript I in DL. Or maybe we're going to print it horizontally with spaces between them. So arrow, arrow, double quote, space, in double quote, semicolon. And once we're done with our for loop, then we're going to hit return, right? So now we're going to write out our E and DL after the closed curly braces. That'll print out our array all on one line. And of course, if we put E and DL here, it wouldn't do it all on one line. I know you have that idea. And there it is. Now, printing an array is something that you do so often that you usually make a function out of it. What I would do is I would make this a function and I would just call the function. You still have to get the size of it and pass that size to it. But we may as well write a function that'll print out that array of doubles. So it doesn't need to return anything, so I'm going to make it void. Void print underscore array. This is going to be an array of doubles. So double DA for array, or just AR for array. Subscript in subscript. That's enough to get us going. And we need a for loop. Now, I know we're going to have to pass a size in, so I'm going to add a size parameter here. So after AR subscript in subscript comma int size. But I'm going to demonstrate why we need the size. What if we tried to calculate the size on the fly? What if we did this? Size is equal to size of subscript AR in subscript divided by size of a double, like that. Just like we did downstairs in our code. That's great, but it's not going to work. The reason why is when we're not in the same context, when we're not in the same function in which the array was declared, size of array does not work. It returns the size of the pointer. A pointer is only 8 bytes long. This array could be 10,000 bytes long, and it's not going to return 10,000. It's going to return 8, which is the size of a pointer. That's not good. So instead, we're going to pass in the size. But now that we have the size passed in, presumably, same business. For parentheses int I equals 0, we could have just copied and pasted and changed the variable name, semicolon, I less than size, semicolon, I plus plus, open curly brace. And let's see it out. Cout less than. The name of the array is AR. The index counter is I, so AR subscript I. And again, let's put it all on one line. So arrow, arrow, double quote, space, end quote, semicolon. So there we go. We can call print array to print our array of doubles. Now it's only going to work for arrays of doubles, but we happen to have one down here, right? So I could comment all this code out and instead just call our new function. I think I'll do that. And yeah, there are better ways of commenting stuff out. Print underscore array, parentheses, DA, comma. Oh, and I do need the size though, so I better uncomment out that line. Right. And so DA underscore size. I might want a separate function that would print an array of ints. I think that'd be a good idea. Let's make an array of ints just so that we have good reason to call the function, to write a new one that accepts integers. So int nums subscript in subscript equals, just put some digits in there. We're going to need the size as always. But this one we could calculate on the fly, right? Because we could calculate it on the fly, pass it in as an argument to the function. Well, why not? Int nums underscore size equals, and you know the business now. It's the name of the array, size of, parentheses nums, in parentheses, divided by size of, and int, in parentheses, semicolon. And now I want to be able to do this, and it's going to be a syntax error. It's not going to compile. Print underscore array, parentheses. What's the name of my array? Nums. What's the size of it? Nums underscore size, in parentheses and semicolon. And it's going to tell me we do not have a function that matches this. We only have one that accepts a parameter of type double, not int. Well, let's go write one that accepts an int. We could even give it the same name. Not possible in the old days. In the 70s, when you were just using a C language, it did not allow function overloading, which is what we're doing now. Overloading is when you provide two functions with the same name but different parameter lists. This one, okay, we're going to save ourselves some time. I'm just going to copy this entire chunk of code, copy and paste it, and change the data type from double to int. It's the fastest way to do it, rather than spend, a minute and a half typing all this stuff in again. That's all I need to do. I made a copy of my print array. And by the way, this stuff had better not be inside main. If you accidentally put these function definitions inside main, it's possible it might work, but just cut them and put them above it. Alright, so that needs to be int. The second version of it is going to print out an array of ints. And since we gave it a nice, good generic name, like AR rather than D underscore array for doubles or whatever, that's enough. And now to compile. This is called overloading. We have two functions, same name, different parameter lists. We could make another one that would print an array of strings. Could make another one that printed an array of characters. Why do you like overloading? Because then you can use the same function to handle different kinds of data. Here it's printing out an array of doubles. Here the same call, it looks like the same call is printing out an array of ints. If we wanted to make one that handled long longs, we could do that. No problem. So overloading is a cool thing. Alright, so here we have two examples of functions. Let's go ahead and do our little bit of review about functions. What is a function? Who cares what the book calls it? It is a named block of code with a return type and a parameter list. The return type can be void if it doesn't need to return a value. The parameter list can be empty if it doesn't need to accept any arguments. So the syntax. is return type space function name parentheses parameter type P1 comma dot dot dot, as many as you were going to put, and then there'd be some kind of body. Right? If you're going to make a prototype out of it, you leave the curly braces off and you just end it with a semicolon. So let's write a function that does something, and then let's write a function prototype for it. Actually, why don't we just cut these functions that we've already written, move them to the bottom of the code, and make some prototypes for them. So I'm going to grab our two print array functions. I'm going to cut them both, and maybe I'll take these notes and move them down there too. I'm going to cut, scroll down to the very bottom underneath the closing curly brace, paste. Now I have two functions, and the code is not going to compile anymore because the compiler doesn't know what a print array is. Identifier not found. Some languages are not this picky. Java is pretty nifty in that no matter the order that you define them in, it figures it out. I believe C++ may be the same way. However, excuse me, C#. However, Python and C++ are very order dependent. So we have to have these defined above where they are used. Well, one way of defining them above where they are used is to put a prototype. So I'm going to take the header of the function, which is just the line that defines it without the curly braces in the block of code, and I'm going to copy it and I'm going to go and paste it up above main. We've done this a couple times already. This is not new business. So paste that, put a semicolon there, but we had two of them, right? We had another one with int. Well, fortunately, the two prototypes are so similar that I can just paste it again, add the semicolon again, and change double to int. Now it should compile again. Hope so. I'll walk around and make sure it's working for folks. Something's looking goofed. I messed up my print function. I wanted it to go to the next line. I forgot to make it go to the next line for both of them, I'm sure. I just need to add one more cout after the loop inside each print function. It just needs a cout endl. Cout less than endl semicolon. If you think the curly braces are superfluous, if you only have one line of code, I might agree with you and I might delete them. On the other hand, you can never go wrong with putting all the curly braces in DL. Now it should work. And we get our two lines of output. Much better. Yeah. Anybody need eyes on the screen? No problems? All right, let me come look. Three concepts about functions I want to hit quickly before we broach the idea of classes. I mentioned them last time. I'm going to mention them again. Default parameters, passing by pointer, and passing by reference. A default parameter is just when you give a value here. Like if you knew that all your arrays were going to be of size 80, you could do that, and then when you call print array, you could leave off the second argument. Don't need to provide a value for the second parameter. Now that's really stupid. We would not want to do that for this kind of thing. But there are times when it makes sense to go ahead and allow default values. Let's make something that might benefit from having default values. Alright, the example I was thinking of is kind of stupid. Because it would be better suited for overloading. Last lecture we saw an example of how we could accomplish the same thing 2 times, one with overloading and one with default values. Alright, so for default values, we're just going to write a function that lets us raise something to the power of 2, but it'll actually, if we provide a second parameter, we can raise it to that power instead. So it's going to need to return a value. So why don't we call it an int, and we're going to call it, I don't know, raise. And it's going to take a value, x, and it's going to take to the power of, so int power. But if you do not specify a power, it's going to just square it. I'm just trying to avoid using the same exact example we had last time. It doesn't help us. So, and now we can use the POW function, just for simplicity's sake. Return POW parentheses x comma power. Now why didn't we just call that in the first place? This is just an example. So when we were going to test that code, I'm just going to make a function that tests it even if we don't even call it really. Void test parentheses in parentheses, open curly brace close. We could do this. Int x equals raise parentheses 10, close parentheses, semicolon. That would square it. Why would it square it? Because this is defaulting to the power of 2. So since we are not providing a second argument to fill in the second parameter variable, it defaults to 2. Or x equals raise 10 to the power of 3, that calculates the cube. And so on. That's the idea behind default values. Now, passing by pointer versus passing by reference. Well, some languages don't support passing by reference. Some languages don't pass by pointer. As a matter of fact, the languages that do, you will find, are remarkably far and few in between. Java does not support pointers or references. Python does not support pointers or references. If you use pointers in C#, it complains that it's an unsafe operation. But here's how it works. What do you use a pointer for? When the function actually needs to change the value. So like if we wanted to write a version of a function called invert, I think that's what it's called. Like if you have x and then you want to take 1 over x, isn't that called the inverse? Math guys? I hope so, because that's what I'm going to call it. It's going to take an int and it's going to divide, put that over 1. So double inverse parentheses, and it's going to take a value x and return 1 over x. But it could fail. Why do I say it could fail? What if they pass in 0? 1 over 0, we don't want to do that. So, and then we're going to have a reference variable which can pass back a value. You declare a reference variable using the ampersand. So bool ampersand OK. If this succeeds, we're going to set OK to true. If it fails, we're going to set OK to false. And the failure condition is if we're trying to divide by 0. If we did not have that ampersand there, we could set OK to true or false, but it wouldn't matter. The calling code would not see any change. Because when it invoked the function, it would just copy a value into that parameter, and you just have a copy. Right? You have a copy of the Constitution. You feel like tearing a hole in it, it doesn't modify the original Constitution. It's just a copy. Because by default, this language is known as pass by copy or pass by value. Now that's all Python and Java and a million other languages support is pass by value, pass by copy. But this language supports pass by reference. We're going to take advantage of it. The first thing we're going to do is check to see if x is 0. If it is, we're going to set OK to false and just return 0 because, well, let's put a purpose of what this does. Returns 1 over x, right? If x is 0, special case, return 0 and set the OK flag to false. I guess I'm going to rewrite this. If x is 0, return 0 and set the OK flag to false. Otherwise, return 1 over x and set the OK flag to true. So, if x equals 0, x equals 0, bad news. OK equals false, semicolon, return 0. And you can guess what we're going to do. Else, OK equals true, return 1 over x. So else, open curly brace, OK equals true, return 1 over x. Bless you. Now I can think of other ways we could have structured it, but I'm not going to bother changing it. So when we call this function, let's just go down to main. I believe main is nearby. Okay, it's fine. It's not. Let's write another function called test2. Void test2, parentheses in parentheses. We could call it test inverse. Anyways, we want to calculate the inverse of some number, but we want to see if it worked or not. So bool space OK. Cout, no. We're going to get the result and check it first before we try to print it. Double space result equals inverse parentheses 0, comma, OK. We're passing the OK flag into it so that that function can change it. If it was not declared as a reference or as a pointer, we would not be able to do that. All right, now we need to check the result. If OK, or if you felt like doing it long form, but a pro programmer probably would not, if OK equals true, but that's superfluous. You can leave off the equals true because it's a Boolean variable. You know it's only going to be either true or false. So if OK, let's see out inverse return space end quote error endl. Wait, no, the value result and then error endl. I'm going to take out the curly brace to save space on the screen. Else, cout quote inverse failed \n end quote semicolon. Now we're going to see if we were calling the test2 function, which we are not, that when we did this it would say inverse failed. It would pass OK in as a reference. Since it's a reference, that function has actually gotten permission to change it because it's not a copy of the value, it is the variable. And so it can be changed. Let's scroll back down to main and put a call to test and test2 in it, just so that we can actually get these things going somewhere. Oh, well, look at that. I've been putting these functions underneath everything rather than on top. Oh boy. Okay, I'm going to totally cheat, and I'm just going to cut main and paste it below everything else. This is lame, but we've written 20 functions now, and I thought we were putting them above main. So I'm going to move my cursor to the top, int main. I'm going to highlight all the way down to the return 0 close brace. I'm going to cut it, and I'm going to go to the very bottom of the file and paste it. Maybe I'll paste it above those comments. Make the comments easy to find. Doesn't matter. And then somewhere in this code, maybe right before the return 0, let's call test and test2. Just so that we see that code actually do something. What I'm expecting to see is the inverse failed. But if I change that value in my test function to calculate the inverse of anything other than 0, it'll work. Passing by pointer works much the same as passing by reference. It's just that the syntax is a little bit more arcane. Let's find one of our test functions, test2. Let's write a function that passes something in as a pointer. We're going to write a function called double that passes its result back via pointer rather than returning it, which is dumb, but we're going to do it just because. Void, no, I can't call it double because that's the name of a data type. Triple, parentheses, it's going to take x and it's going to return it in a pointer. So int py. So int star py. It means that py is a pointer to an int. It's going to contain the address of the variable that we want to change. Now here what we're going to do. Star py equals x times 3, or 3 times x. So whatever we pass in by address here is going to get changed to 3 times whatever we pass in. So if I declare a variable, int num is equal to 3, and I do this, triple my num, and I want you to write that result out to a new variable. Well, I need a new variable for this to work. Maybe I'll just call it num2. So int num is equal to 3, int num2. I want you to triple num, and I want you to store that result in the memory address pointed to there. So we're passing not the copy of the value, but the memory address, just like if I told you my address. You could drive over to my house and change my house. And so num2 is going to be triple of what num was. So if we see out arrow arrow num, arrow arrow quote, tripled equals, end quote, arrow arrow num2, arrow arrow endl, and then we run it, we're going to see that 3 tripled equals 9. But what happens if we pass in the same variable, the address of the same variable? What if I passed in num and then the address of num? Well, it's going to erase the num variable and replace it with those contents, num times 3. So if I do this, triple num, and I want the result stored in the address of the num variable, then if I print them out, cout less than num, how about less than quote num now equals space end quote less than num less than endl. We're going to see that num has actually been changed. We passed it in, but it got changed by its address and passed back out. And so it's going to print 9. Num starts off at 3. We pass it in. Its memory address gets overwritten with the parameter times 3. And so 3 tripled is 9. Now num equals 9. if all we wanted the function to do was to change a value and not have the ability to store it in a different address, we could just pass it in by address, by pointer, and only have one parameter, right? I could take that one out entirely and just use this one both as input and output. But I'm going to leave it alone. I'm going to leave it alone. I think this is a good enough example. But I better put some comments here. Py is a pointer to an int. The function calculates 3 times x and stores the result in the memory address that the pointer points to. And that's what the syntax means. Star py means don't change py, change the memory that it points to. We should add some comments to this one as well. Our inverse function. No, I guess we already did. OK is a reference as indicated by the ampersand. So the function can modify it as it is not a copy of the argument, but actually is the argument. It's the difference between me handing you a photocopy of $1 and me actually giving you the dollar. This here, we're actually giving you the dollar. And if we remove the ampersand, we're passing in a photocopy of the dollar. If I actually give you the dollar and you scribble on it, well, now we have a dollar with a scribble on it. If I give you a copy of the dollar, by taking that out, you can scribble all over the dollar, but I still have my original unchanged dollar. All right, we're going to switch gears. We've talked about arrays, we've talked about functions. We're going to talk about what a class is. I'm going to go and find main so that I can put this stuff right above main. We've seen structures. Struct. I don't know what I'm going to call this. Rect for rectangle. And a rectangle is going to have a height and a width. So int h, comma, w. In this language, unlike Java, when you're done declaring your structure, you have to have that semicolon there. Now let's create some rectangles. Rect space R1, comma, R2. And we're going to set different height and width values. So R1 dot H is equal to 10. R1 dot W equals 10. It's a perfect square, really, right? 10 by 10. R2 is not going to be a perfect square. R2 dot height equals 2. And R2 dot width equals 20. Whatever, right? Completely different size. The point of a structure is that you can cluster a whole bunch of data under one name, right? Now I've got 2 pieces of data that I'm accessing just by R1. And I can pass in R1 into a function, right? Or I could pass in R2 as a function. Now, structure can have as much data as you need, not just 2 pieces of data. It could have 20. It could have 2,000 pieces of data. It could contain an array. A class is just a structure that also contains functions. We're going to declare a class now. Struct, nope, that's class. Class space circle. Or why not make it a triangle? Triangles also have height and width. It's just that if you calculate their surface area, it's half as much. So class triangle, open curly brace. Again, it's got a height and a width. I'm contemplating making them doubles though. So double h, comma, w. And I'm going to add a get area function note to self, add a get area function. But I'm not going to do so yet. I just want to make sure that I can create a triangle first. And the truth is I cannot. Well, I can create it, but I'm not going to be able to set its height and its width. So if I do this, triangle space T1, comma T2, and I feel like setting it to be a 2 by 2 triangle, T1.h equals 2. Yeah, we can kind of see an error already. It's underlining my... These are known as properties, or member variables. These are members of the triangle class. They are properties, right? I have properties. I'm 5'10" or whatever. I'm 107 years old. My hair is white, whatever, right? Those are my properties. Why can't this see it? Because these are inaccessible. By default, all of the members, all of the properties / member variables of a struct are public. By default, all of the properties / members of a class are private. And there's a good reason for that. There's a good reason for making data private, but it sure is hindering us from being able to set these values. So we're going to make these public. If you've used Java, you're used to putting the word public in front of every variable definition. But in C++, you just do it once, public colon, and then everything after it is a public variable now. And bingo, all of a sudden we can change those values. Okay, so all well and good, but why don't we just make it a structure? Because we want to add a get area function. The area is going to be height times width divided by 2, just because that's how you calculate the area of a triangle. Base times height divided by 2. So, double space get underscore area, parentheses in parentheses. Open curly brace. Return 8h times w divided by 2. I'd rather make it 2.0 just because I always want to prevent integer division. In this particular case, I don't have to because these already are non-ints, but I'm paranoid. So I'm going to say area of triangle is 1/2 h times w. Just explaining what that formula is. So you have two keywords. Public sets the members after that keyword to public, meaning that the code that is trying to get a hold of it can do that, so that we can set those values, or so that we can retrieve them or print them out or something. But since there's a public keyword, there's also the private keyword. We could switch back to our variables being private, and I can't think of a reason to do this right now, by doing that and then listing some stuff. I can't think of any right now, but I'm going to go ahead and list that public makes the members accessible to the client code, the driver code, the main method, whoever is calling it. Private makes the members inaccessible to the client code. Now, why would you want to do that? I want to be able to access all my data. Well, that's not necessarily true. There's the concept of data hiding or encapsulation. You may have data inside your class that you don't want a programmer using your class to be able to change. Like suppose you're trying to encapsulate all file access so that all they need to do is specify a file name, and then you do all the magic of making it work so that they don't have to use a file handle. Well, if you make a file handle variable as part of the class, and you make it public, then they can change the file handle. They can set it equal to 0, which is then going to crash the program the next time it tries to access that file. The idea behind a class is that you want to keep your data in as valid a state as possible at all times, and you don't want the calling code to be able to mess it up. I don't want somebody to be able to change my file handles in between calls. And you say, well, who would do that? Trust me, if there's a way to break it, then the other programmer working on your team will break it. Or you will. You'll forget that you should not be changing that piece of data, and you will. Okay, so we have a triangle class, and we have a getArea function. Let's get the area of this T1 triangle. So double, whoops, let's just do this. Cout less than, area of T1 triangle is space, end quote, less than T1 dot get underscore area, but it's a function. No, it isn't, but I'm going to call it a function right now. Parentheses in parentheses, because functions are called with a parameter list that we could fill with arguments. Now this one doesn't have any parameters, so we don't need to give it any arguments. All right, I said it's not a function. That's because a function that's part of a class is actually known as a method. New word, it's a method. If you go and take C# or Java, there's no such thing as a function anymore. They're all methods. There's no such thing as a function in those classes because there's no code that is in those languages because there's no code that exists outside of classes. Absolutely everything is a class in those languages, including your main code. So everything is a method. There's no functions in those. But a method is just a function that's been attached to a class. Notice that when we called this function, when we called this method, I'm doing that on purpose this time. I'm not actually making a mistake. It's attached to the T1 object. T1 is an object of type triangle. Now really it's just a reference to the object. The object itself is hanging out in memory, but let's not get too subtle. We're going to say that the class is triangle and T1 is an object of type triangle. So this creates a triangle, creates an object. This also creates an object. We actually have two triangles going on, but we've only used one of them. Okay, in order, I don't know who made this decision, but although I'm making a big point of saying that you have structures which are data, and then you have classes which are data plus functions, honestly, a class and a structure are absolutely identical. There's no difference between them. You can stick functions inside a structure just like you can a class. The only difference is that the default data type for a structure is public. So you wouldn't have to put that public keyword. Whereas the default data type for a class is private. It's almost like you don't even need the word struct anymore. But it was a big, really important part of the C programming language, which makes me wonder why they didn't just not create classes and reuse the struct keyword, because now it supports both things. But they didn't. But dump that statement and just think of a struct as being data and a class as being data plus functions. We may as well even add that as a comment somewhere. A struct is a collection of data, which you can call member variables or properties. A class is a collection of data, and the methods, parentheses, functions, that use that data. Now, as always, you can get more and more precise. That is not a correct statement. It's close. But a structure is the blueprint for a collection of data, right? This is not actually a collection of data here. It's just a blueprint for it. Until we actually created R1 and R2, we didn't have any data. So we should come back here and modify our definition that a struct is a blueprint for a collection of data. And a class is a blueprint for a collection of data and the methods that use that data. Once you start using C++, there's really no reason to use the struct keyword anymore unless you're trying to write something that's backwards compatible with C. May as well just stick everything in a class. And if it doesn't need any methods, so be it. You don't have to put any functions inside a class. Because you could get away with not having the struct keyword at all if you were just willing to write everything as a class, and that's what Java and Python decided to do. There's no such thing as struct. If you want to make a struct, you just write a class that doesn't have any functions attached to it. So, we've defined what a class is and what a struct is. An object is a so-called instance of a class or struct. What do I mean instance? Well, I have this theoretical house. I've bought the blueprints for a house. Now I'm going to build that house. I hire, some builders, and they go and they build that house. That is an instance of the house. If we're going to get all techie about it, instead of using the word build, we would call it instantiate. Got to use as fancy of terms as possible. Down here, we are instantiating the triangle class. T1 is an object that is an instance of the triangle class. But you can have multiple instances, right? Now we have 2 instances of it. We could create 70 instances. Or if we created an array of triangles, we could create 200,000 instances by declaring an array of triangles. What would that look like? All right. I'm not totally sure this is going to work, but let's find out. Triangle, big mess, subscript, 100,000. If that compiles, we've got now 10,000 different triangles, right? And I could change the height of one of them. Big mess, subscript, 500. In subscript dot h is equal to 3, right? And big mess subscript 500 dot w equals 4, right? And then I could find another triangle by using another subscript and change those. So an object is an instance of a class or struct. Informally, you can say, well, I can't even think of where I was going with that. When the object is being created, I'm going to use the word constructed, just like, builders constructing your blueprint. That is called instantiating the object. Let's take a break. Is anybody getting syntax errors that you wish my eyeballs would hit? Right. Okay, so one more thing we want to do with our class. And that's what's known as adding a constructor. Well, I'm not sure why it's not called adding an instantiator, since that's what they decided that's called when you construct something. But what is a constructor? It allows you to pass in data. It'd be real neat if when I was creating T1, I could specify that I wanted it to be 2 by 2 without waiting and setting those 2 values. There are some slight differences between C++ and Java, and I want to make absolutely sure I get it right, so bear with me for a minute. All right, so what is a constructor? A constructor is a method with the same name as the class with no return type, not even void, because it's returning the object itself. That is called when the object is being created or constructed. So when I make a triangle, here's what I want to be able to do. I want to be able to do this. Triangle T3, and oh, by the way, you're a 10, 5 triangle. Now that doesn't work because I haven't added a constructor method yet. I'm going to comment that out, and then I'm going to come back to that idea after we actually create the constructor. So I'm going to come up here and add a constructor to it. Here's my triangle class. I like putting the constructor near the top, right underneath my variables. It's not, doesn't matter. That's what I'm going to do. So, it doesn't even have a return type. Triangle, parentheses, in parentheses, curly brace. Let's see out area, let's just prove that it's being called. So see out less than, triangle constructor being called, or was called. \n, end quote, semicolon. That's enough to prove that it's working. We know we're creating two triangles. Actually, it's going to go absolutely nuts because we didn't only create two triangles, we created 10,000 more. So we're going to see a lot of print messages come up. Each time a new triangle is being called, it's going to be created, constructed. It's going to do that. So this is a constructor. You could think of it as a default constructor because it's not accepting any data. You can also add parameters, just like you can to any other function, any other method. Now we're not accepting functions, parameters here either, because it didn't need to, right? We were asking for information about the triangle. We were not changing it. Well, let's see what happens when we run it now. I'm expecting to see 10,000 messages. Yep, there we go. We're creating all of our triangles. Why don't we close that? All right, so we just added this code. We added a constructor. The constructor is called when the triangle is being made, when a triangle object is being made. Now, I don't really want it to print out 10,000 messages, so I'm going to comment that out. But maybe I am going to change the height and the width of the triangle when it's being created. By default, it's a 1 by 1. Right now, it's defaulting to 0 by 0 because we haven't assigned any values here. So what we're going to do is we're going to use what's known as the this reference. And don't worry, when we come in on Monday and I do my little 30-minute lecture before we spend the next 2 hours on the exam, which is not going to take just 2 hours, we will hit this again. So this hyphen greater than h equals 1, semicolon, this hyphen greater than w equals 1. Now what does this syntax mean? It means that we have a pointer and that we're trying to change a piece of data that's attached to that pointer. This is known as the this pointer. It means this triangle. So we are changing the h value of this triangle to 1, and we are changing the w value of this triangle to 1. And why would you care about sticking that this keyword in front of it? What if we had two variables? Don't type this because I'm going to delete it. But what for some reason I declared two strings, and then I did h, is equal to 1, and width is equal to 1. Well, now that's a syntax error because H and W, well, it's not saying it is. Oh, fine. Anyways, to eliminate confusion between local variables and parameters and members, to access the properties, the member variables, you prefix them with the this keyword, the this pointer, followed by the hyphen greater than. Get rid of those. So now by default, every triangle we create is going to have a height and a width of 1. Everybody got this part typed in. Slow me down if you do not. Are we okay? All right. So back down here, we created 2 triangles, but we only set the values of one of them, right? We set T1.h and T1.width. Well, let's get the area of the T2 triangle. So I'm just going to copy that entire line. As always, I just move my cursor to the beginning of the line, hold the Shift key and press the down cursor, down arrow, and then usually I use Control C, paste it, and make it say the area of the T2 triangle is T2.getArea. And it should say, right, 1 times 1 divided by 2, it should say that the area of the T2 triangle is 0.5. And so the area of the T2 triangle is 0.5. But we haven't been able to make it do this, where we can specify the height and the width as we create it, so we don't have to do this business of setting them individually. Well, we're going to go and add a constructor that does that. We're going to so-called overload the constructor because it's going to have the same function name, the same method name, but it's going to have parameters. This one does not have parameters. Oh, delete that string h comma y. I think I said not to type it, but get rid of it. All right, now let's make another one. Triangle, parentheses, double h, comma, double w. We're passing in the height and the width now. And so this hyphen greater than h is equal to the h parameter variable that was passed in. And this hyphen greater than w is equal to the width that was passed in. So now we're going to scroll down to main, and we're going to prove that we can create a triangle specifying those 2 values. So triangle T3, parentheses, and whatever size you want your triangle to be. Want it to be a 3 by 3 triangle, want it to be a 10 by 10, which would have an area of 50. Let's prove that. If you still have that statement in your buffer and you can just paste it, go ahead and do so. Otherwise, go down there and copy it and paste it again. And make it say the area of the T3 triangle is T3.getArea. Now when we run it, it's going to say the area of the T3 triangle is 50, because 10 times 10 divided by 2 is 50. And we did not have to set the parameters individually. Now if you only have 2 properties, it's not that big a deal, right? But if you have a bunch of properties, it might be a big deal. And your constructor can do things other than setting properties. It can allocate memory, it can declare arrays, it can open files and pull data out. So as soon as the object is created, it's already fresh full of data, like right that it loaded from the disk or gathered from the internet or whatever. You could stick all that in the constructor. Now you might not want to put too much in the constructor. I don't think I'd hit a database just to load up something, right? I mean, just to create an object, because then if you do something like this, be making 10,000 file accesses or something, that wouldn't be too good. So what have we learned? A constructor is a method with the same name as the class, with no return type that is called when the object is being created. By default, the compiler gives you a default constructor with no parameters. You don't have to put it. We made one. We made a default constructor, but the compiler gave us one already, right? Our code was working okay without us adding that constructor. You can create your own parameterized constructor that accepts arguments, right, to fill the parameters. So you can make a custom constructor. Right here we have a custom constructor. Parameterized constructor. That's about enough about classes. Now the question is why did we have this here? Why did we have 500? Why were we doing it twice? The thing is that big mess is an array, and so we were narrowing it down to be a specific element in the array. This is a 500th, actually, yeah, the 500th element in our huge array. And if we wanted to change a different one, we would use a different number for 500 there. Like if I wanted to change the H and the W of the first element, big mess subscript 0 dot H equals 3. Big mess subscript 0 dot W is equal to 9. Okay, now we have a new triangle. And we can calculate the area of that one as well. Double area equals big mess subscript 0 dot get underscore area, parentheses in parentheses, just like that. Any questions over these ideas? I know they're kind of abstracted, be thrown in at you, but we've already talked about structures, and you already know what functions are because we've been using them all semester long. And so a class is just a structure that we tacked methods onto. You just gave those functions a special name. Sorry, that we've tacked functions onto, but we gave them a special name of methods. I think we ought to do some review. All right, so I'm going to scroll down here so that I can just start a big comment type freeform. Let's start last first, right? I'm not going to ask any questions about classes, or if I did, I'd give you the answer, right? Because we're introducing them too late into the semester, which is kind of a problem. It's just hard to fit in everything, and we missed a day. Okay, so starting at the end, arrays. Know how to do things like this. Write a line of code that creates an array called scores that contains 10 ints. Need to know how to do that. We need to know what an array is. Know what an array is. What is an array? It is a variable that contains a series of values known as elements I almost wish I was rewording this. The elements all have the same type. The elements are accessed by their subscript. How do you allocate an array? Arrays are allocated using the square brackets. Arrays can be initialized as they are being allocated. So you want an array of 10 ints called scores. Int scores subscript 10 in subscript, right? That'd work. Or you could do int scores subscript in subscript and then fill in 10 zeros with the curly braces, the initializer list. Now if it's 1,000 or 10,000, that would be stupid, but you know, 10's not that many. There's 5, 6, 7, 8, 9, 10. Right? Two ways of accomplishing the same thing. So it is a variable that contains a series of values. The elements all have the same type. The elements are accessed by their subscript. They are allocated using whatever operator, just like this. And they can be initialized as they're being allocated. So, something important about arrays. Very important. Arrays are fixed in length. They cannot grow or shrink. Once you declare it to be 10, you cannot add an 11th item. If you want to add an 11th item, you better allocate a brand new array and then copy all the values in. It's like you have an apartment complex that holds exactly 200 apartments, and there's no room for it to grow. So when you want to move the 201st family into it, you have to build a brand new apartment complex somewhere else that is larger, and then move one by one all those families into it, and then you can blow up the old apartment complex. So arrays are fixed in length. They do not grow or shrink. There's another data structure called a vector. A vector, which you could call a list in Python, does grow and shrink. So in some ways they're better. They're just slower. Why? Because another attribute of arrays is that they are contiguous in memory. Contiguous in memory. I think I spelled that wrong. Contiguous in memory. Meaning that every one of these values immediately follows the other value. They're all nice in a row. You know, if this is in byte 200, then this will be in byte 204, and this will be in byte 208, and that'll be in byte 212, and so on. Really easy for the processor to get that data. It just issues one call, you know, to the memory manager. Yo, I want, you know, the next 32 bytes, and it gives it to it so it can process them. So arrays, elements are contiguous in memory, meaning they just follow one after the other. They all have to be of the same type, meaning that if I declare an array of ints, I'm not going to be able to stick a string in there. I'm not going to be able to put my name in an array of ints. What if you do put a value here, but this number does not match the initializer list? Then the rest of them are set to 0. So if we do this, int nums subscript 4 in subscript equals curly brace 1 comma 2 in curly brace, what do we have in our array? Our array looks like this. It's got a 1 in it, a 2 in it, and then it has to pad it out to 4. So put some zeros on it. That is used as a quick and dirty way of initializing the array to all zeros. Int more nums 10,000 is equal to, and I don't want to have to put 10,000 zeros, you know, like this. Instead, I just put 1 there, and then the rest of them are all set to 0.
we have to put that for 0?
If you leave that out, very, very, very good question. In this language, the memory is not initialized, and whatever was in those bytes will still be there. We can give an example of that. We can come up here right after our calls to test 2 and create an array, events or whatever. Let's make an array of characters. So char data subscript 100 in subscript semicolon. And let's write a for loop to print that out. For int x equals 0. I'm going to be really lazy and put x less than 100 there, rather than make a size variable and stuff like that. Let's print out data subscript x. Data subscript x in DL. Now it's in debug mode right now, meaning that the compiler is adding some debug code which is going to not allow this to be uninitialized memory. Instead, it's going to initialize it with a very specific value that's supposed to stick out like a sore thumb. So when we print it out, well, what are we going to see? Nothing, because I already had a variable called data. Alrighty, C data, and then print out C data subscript x. Alright, see all that? We didn't want to see that. Let's print out the integer version of that. Let's put int parentheses around that. We're casting it to an int, and of course we know that there are 3 different ways of casting an int. Look at that. Oh well, I've got some warning popping up. Alrighty, so negative 52. That was just what happened to be in that RAM that those bytes occupied. If I change it to release mode rather than debug, it removes, it strips the, it doesn't add all that debug code. So all the RAM is not going to be set to that negative 52 value. Instead, what we're going to see, okay, fine, it is a bunch of zeros, but it didn't have to be. It could have been whatever was in memory at that time. So if you did this, then you're sure it's nice, fresh, clean, full of zeros. Does that make sense? Yeah. I don't know if I just spent 2 minutes saying what I could have said in 15 seconds. I was trying to show you garbage in it. We saw a little bit of that, right? If I go back to debug mode where we were seeing that negative 52 and we run it, it's not going to say the negative 52s anymore. It's all nice, clean data ready to use. All right. If this array is 1,000 elements long, what's the minimum index? What's the smallest number you can use as a subscript? What's the first element? 0, right. And what's the largest element? And it's not 1,000.
999.
Yeah, 999. Okay. So, if the array is 1,000 elements long, the range of indices, whatever, subscripts, is 0 through 999. Just like if we had 10 elements in our array and we wanted to count them out, you start at 0. My fingers go up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 elements. Just went from 0 all the way up to 9. Know how to calculate the size of the array, which we've demonstrated several times in the code already. we're going to skip these questions. One thing that I've managed to miss showing you, I think, and I'm not even sure I showed it to you last Monday. You can tell me if I did. There's two ways of printing an array. That's one way. But there's another way. Let's declare an array of strings and demonstrate both ways of printing an array. One is by index. The other is what's known as a range-based loop, or a for each loop. The book calls it a range-based. The more common terminology is for each. So we're going to make an array of strings called pets. String pets, subscript in subscript, and let's stick Snoopy, end quote, comma, quote, Garfield, end quote, comma, quote, Tweety. Why not get three different universes there? End quote, curly brace, semicolon. Two ways of printing it out. One is by index. Print by index. Same way we've been doing it with a for statement. For int I equals 0, I less than, and yeah, I should calculate the length of the array rather than just hard coding a 3. That's lame. I plus plus, and then cout less than pets subscript I in subscript less than ENDL. That's one way. The other is with a for each loop, a range-based loop. Not even sure where they get the term range-based. For, parentheses, string, E for element, or V for value, or something, anything, colon, pets, cout, arrow, E, arrow, ENDL. There we go. It's that easy. We're saying for each string in the pets array, print it out. The syntax is considerably cleaner. If I ask you to print an array out, you may as well use this. Even though every example I gave, because I was teaching C the hour and a half before, was this syntax. And this is the one you should really burn into your brain, but this is awfully handy. So this is for each, also known as range-based. I'd kind of like for you to be able to do both. So, back down here, if I didn't specifically say it, know how to calculate the size of the array, or an array, any array, right? Know how to print the array, either with an index-based loop or a for each range-based. There's examples of that up higher. All right. Now I'm actually probably going to leave some of this stuff out. I may not put every one of these questions on the exam.
Professor Thompson,
Yes, sir.
please scroll up a little bit to the
Ooh.
for each loop.
Sorry about that.
There you go.
There we go. All right, so there is a quiz over this chapter. It just opened up. It's not fair for me to open up something, especially we haven't even finished the chapter. Why don't we go and take it together, and then that'll serve as a little bit more review. We may not get out of here as early as I thought, but that's okay. Get our money's worth. So go to quizzes in Canvas if you want to do all this at the same time, and I recommend everybody do it. Go to the Chapter 7 review. Alrighty, which of the following statements are true? Is an array a variable that contains multiple values of the same type? Isn't that the entire point of an array? Yeah. So, the values of an array in C++ are stored in adjacent memory locations. Yeah, one after the other, right? That's the big deal about them. It's the fastest kind of memory structure that holds multiple items. Arrays are declared using square braces. Is that right? Yeah. Now, if we're talking about initializing them, you stick them between curly braces. Unlike Python, where you initialize them and create them with. All right. Once you allocate an array, its size will grow and shrink automatically. Is that true? False. And if you declare an array of ints, can you store strings in it? Nah. All righty. How about this one? Write a line of code that will declare an array of type int. Should be called tests. Should be 5 elements long. You don't need an initialization list. Don't forget the semicolon. Y'all know how to do that. Go ahead and type for 30 seconds. Then I'll show you the answer. So what's the data type? int. What's the name of the array? Tests. How many elements do we want? We want 5. And I say to leave off the initializer, so we don't have to. All right, now we're going to do another one. Write a line of code that will declare an array of type string. Well, we know what the first word's going to be. The array should be called colors. Well, we know what the second word's going to be. Since it's an array, we have to use our square braces. And then use an initializer list to set the elements of the array to these values. Now, I made this so easy. You could just copy and paste that. But we know what an initializer list looks like. It's got an equal and a curly brace and then some values separated by commas. Red, end quote, comma, quote, green, end quote, comma, quote, blue, end quote, semicolon, excuse me, close brace, semicolon. Don't specify the length of the array. While it's not an error to put a 3 there. Now I said don't specify, so I'm going to leave that out. That making sense, gang? We've been doing this for a couple days. We ought to know how to do it. True or false? Somebody tell me. This code will initialize every element in the scores array to 0.0. Yeah, that's true, because the first one gets set to 0.0 and then the rest default down to 0. Now, if this was 1, this code would initialize every element in the scores array to 1. That would be false, but I'm not going to try to trick you up because only the first element would be set to 1. Alrighty, which of these statements would print the first element of the following array? This is real easy. Top one. Yep. Which one will print the last one? Yep, scores 9. What would be a good way to calculate the number of elements in an array? So we just need to know how to do that size of business. Which of these look best if they're not randomly ordered on your screen? The size of the array divided by the size of the int? Yeah, that's looking real good, but let's keep checking. The size of the array times the int? No. The size of the int divided by the size of the array? No. Alright, so it's got to be that top one, at least on my screen. If you have this array, what is a good way to print the array? 2 of them are correct. Oh boy, there's 6 different choices. Anybody eyeball one? Do any of these look like a range-based for each?
Yeah.
The first 2 look like a range-based. And actually even the last one does too. So of these three, which one looks best? Pick one and I'll tell you why it's wrong if you get it wrong. Does the first one look good?
Yeah.
It actually is correct, and I'm not sure why the first answer is correct on all of these, but it's correct. This is the right way of doing it. For int x in IA print x. Now this is wrong, and a lot of people choose it on if I throw this question on an exam. Int x, for every x in IA, print out IA subscript x. No, 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 that's mixing the two syntaxes. If you're using a range-based, if you're using a for each, you don't want to use subscripts. So that's not right. And then down here, for int x, for every x in IA, print IA. Well, that doesn't make sense. We want to print x. IA is the array. We want to print every element of the array. So that's not right. All right, now of these three, only one of them is correct.
What would be the third one?
Let's see. Oh, there's just a stupid syntax error there. In fact, all three of these have a stupid syntax error. Should not be less than, less than. Okay. Well, I should just roll with it and I'll edit this quiz for future generations. I is equal to 0. I is less than num. I plus plus. It's not this one. Why? Because it's no longer a for each. We do need a subscript. And so when you said third, you meant that one, right?
Yeah.
Because that's correct, right? I is equal to 0. I is less than num. I plus plus. Print out IA subscript x. Those are the two correct. Alrighty. I don't recall if we've talked about parallel arrays today. So the exam's not going to mention it, but what is not true in these four statements? Parallel arrays are two or more arrays that contain related data. Yeah, that's true. It's like having a spreadsheet. You have multiple columns. They're related to each other. Sales for January, you know, and the month name, January. So that looks true to me. To use parallel arrays, elements of the same subscript are related to each other. Does that sound right? That's like rows on a spreadsheet. If you have columns and rows, are the elements in the same row related to each other? Yeah, they're related by their row number. So that's good. Parallel arrays may be of different types. Now, honestly, that's true. You could have an array of strings, and then you could have a parallel array of turtles, and a parallel array of triangles, and so on. You just can't have one array that contains two different types in it. And then parallel arrays should be of different lengths. Why is that false? Parallel arrays have to be of the same length. All right, I'm getting worried that I didn't use the term parallel arrays in the last lecture either. Okay. I'll skip. We'll just answer these and go on. There's not going to be any exam questions over it, or if there were, I'd give you the answer. Parallel arrays are two arrays of the same length. I have a list of kids and their favorite foods. I have a list of 10 kids and 10 favorite foods. They have to be the same length. If I have 11 kids and only 10 favorite foods, then the last kid's not getting the food. Right? Or I could have one column full of names and another column full of social security numbers and a third column of birth date. Right? They better all be the same length. So parallel arrays are two or more arrays of the same length where the elements are linked by their subscript. The first kid eats the first food. The second kid eats the second food. So index 0, index 0, index 1, index 1, just like rows in a spreadsheet.
Did you do an example of that using 3 kids' names, their favorite colors, and their favorite desserts, like that? Or is that something
Yeah, that's the exact same idea. Okay, so I did cover it.
Yeah,
I'm still going to leave it off the exam because I don't think we've pounded it in with a hammer.
We didn't use the term parallel arrays.
Oh, hush.
Yeah.
All right. All right, we didn't talk about partially filled arrays, so I'm just going to give you the answer. If it is unknown how much data an array holds, you may wind up using a partially filled array. A partially filled array is when not every element contains valid data. You don't know how many test scores are going to be, and since the array doesn't grow and shrink, you allocate 100, right? You could conceivably hold 100 test scores. You may only have one. If you only have one, it's a partially filled array. The rest of them do not have valid data, so you better have some counter to keep track of how many good pieces of data are in it. If they haven't even started filling it, that counter would be 0. If it's filled to the max, that counter would be 100. So you use a counter variable to keep track of the number of items, and you better make sure the array is large enough to hold them all. If you teach some weirdo class that gives 200 exams, well, you better make the array large enough to hold all of that. And then lastly, if you have a counter variable telling you how many elements are in the partial array, you want to stop there, right? If there's only 10 good pieces of data in your array of 100 scores, you better only get the first 10. So this is a false statement. When you process the array, you should go from beginning to end, ignoring the counter. Nah, because then you're plowing past the good data into bad data. Okay. We haven't talked about comparing arrays. But just like copying arrays, when you compare arrays, you compare them element by element. I want to see if this is my array of ages. This is my other array of ages. I want to see if y'all are the same age. I ask you, yo, what's your age? You tell me it's 25. Yo, what's your age? You tell me it's 26. Okay. No, not a match. But if y'all have been a match, then I go to the next. What's your age? You tell me you're 32. I check. You're 27. No match. You just check element 0. This is element 0, element 1, element 1, element 2, until you find something that doesn't match. So to compare two arrays, you do compare them element by element. A loop is the best way to do that. I don't recall talking about two-dimensional arrays, but if you have a two-dimensional array, it's just a grid, like a spreadsheet. And so if it's 4 rows and 3 columns, how many, like if it's a 3x3 tic-tac-toe board, how many squares are on it? 9. So it's not going to be 7. It's not 3 plus 4. It's 3 times 4. And then a nested loop is not a valid way. No, a nested loop is the only way to access the data in a two-dimensional array. And this is an example of a range-based for loop, just true or false. Is that looking pretty good as being a for each loop? Yeah, that's true. All right. See, there were several questions that I wasn't confident we had covered. I knew we hadn't done partially filled arrays. I knew we hadn't done comparing arrays or 2D arrays. So y'all get the answers, and they're not going to be on the exam. The other stuff we ought to be able to do. We've done them more than once. Initializing an array, printing them out. Yes, sir.
So in question 3,
Yeah.
when it said to list out or like use the initializer, is it okay that I put spaces in between?
Yeah.
Yeah.
Do you remember on the last test or whatever, it lists 7 different correct answers? I try to accommodate them all, and if you come up with a creative spacing that doesn't match, I'm still going to give you credit for it. What would be even better is if I made it an essay-style question, so it's not limited to just 15 characters, right? And that's what I'll do. Have to grade them by hand, but I have to anyway, so why not? All right, we've talked about arrays enough. Functions. What do we need to know about functions? Write a function prototype. It's just going to be a prototype for a function named, I don't care what we call it, Googie, that doesn't return any value and accepts an int named x. as a parameter. Now I said it's a prototype. Since I said prototype, you don't put a body. You just put a semicolon at the end. You know how to do that. I shouldn't even have to explain it. But if it doesn't return a value, what's the keyword? What's the return type? Void. And the function is called googie. And it's got a parameter, which is an int, named x. And it's a prototype, so that's all we need. All right. Every function definition, every function must have a return type, even if it doesn't return anything. If it doesn't return anything, you declare it as void, but it's got to have that or else the compiler doesn't know. So typically, where are you going to put your prototypes? Yeah, you're going to put it before main, or you're going to stick it in the header file. Prototypes go before main or in a header file. Is it true that a function can only have one return statement in it? Some computer scientists would argue that it should only have one return statement, but you can put 20 different return statements, right? Like if x equals 1, return animal, else if x equals 2, return, baby, else if x equals 3, return cradle, right? You can have as many return statements as you want. So a function can have more than one return statement. Not in a row, not return x followed immediately by return y, because as soon as it returned x, it's left the function and it's not going to do anything after that. All right, we talked about static variables only once. I don't mind giving you the answer here because we've only talked about them once, but you could also hit the book about it. So a static variable, what is it used for? It maintains its value between function calls. In other words, it's not reset every time the function is called again. Otherwise, all local variables are reset. Otherwise, all local variables are reset between function calls. Know the difference between a local and a global variable. Where is a global variable defined? Yeah, it's above main, so that it's accessible to all the functions. A local variable is inside a function, so it's not accessible. It's only accessible to that function. Alrighty, the good old question from the last exam that we hadn't covered adequately. If you have this, A is equal to 10, B is equal to plus plus A, is B going to equal 10 or 11? Will B equal 11? And do the rest of y'all agree? Well, you should because it's correct, but why? Because the plus plus is in front of the variable, meaning it happens first. Yes, because plus plus prefixes is in front of the variable, so it happens first. How about if we have this? A is equal to 7, B equals A plus plus. Will B equal I'm going to revise this. Will be equal 10 or 11 question mark. It will equal 11, not yes. Modify the wording of that. Will be equal 7 or 8. The plus plus follows a variable, so what does that mean? It's the very last thing that happens, so the 7 gets copied into B. 7, because the plus plus is a suffix, it's after the variable, so it happens last. Happens after all the copying does, happens after the equal sign and everything. If you have a for loop, you have a do loop, and you have a while loop, and you have to link them up to whether it's a pre-test or a post-test loop. There's only one of these that's a post-test loop. Which one is it? Yeah, it's do. Do is the post-test. So the pre-test loops are for and while. The post-test is the do loop. Know how to eyeball how many times something is going to be iterated. What do I mean by that? If I do for int I equals 1 semicolon I less than or equal to 9 semicolon I plus plus, how many times is that going to iterate? Just count them out on your fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9. It would iterate 9 times. What do we do this? For int I equals 3, I less than 7, I plus plus. Just count it out on your fingers. But it's going to stop before it hits 7, right? Because it's less than. So 3, 4, 5, 6, and it's going to stop there. So in general, if it's less than, something's bugging me about this definition I'm about to give you, so I'm going to not even give it to you. That would iterate 4 times. All right. 5 minutes away from being done. Actually, that's the last chapter that's on the exam. Otherwise, we'd be going back and reviewing stuff from the other chapter, and it's not my goal to unnecessarily clutter this exam with stuff that we already covered on the other one. I mean, you know, programming languages are cumulative. You do have to know what a variable is and a double, right, and an int, but I'm not going to specifically ask that. We've already covered that. Might make it easier, but it'd make it longer. It's not going to be a hard exam. Most of y'all will finish it in an hour, and we're going to be here for 3, so don't sweat it. We'll do a short review of classes and objects, just because I want you to walk away from the class with that fresh in your memory, so that when you go and take Java, as I hope all y'all do, y'all are good students, it's fresh in your brain. Yeah, that was smart. I can't believe I caught it. Are there any questions? If you redo the quizzes, it's probably a quick ticket towards getting most of the test questions right. Look at this review, right? If you can do everything that's in this review, we pretty much have covered the exam. Any questions? Oh, good. Oh, well, not good. Any homework that you've been stuck at the end? It's fine if you want to ask questions about homework. Got 30 minutes. No questions? Well, all right. I'm going to go ahead and make the Dropbox, and then I'm going to be hanging out. So I need to help, you know, with hers, and I'll help anybody else with theirs as well.